Hi, welcome. Here's the review, and remember it's worth double, so make sure you do it. Now there's 4 points. You can kind of think of each section as 10 points. I'm going to make a video just on arc length, then sector area, then circle equations, then these grandma table type questions. Okay, so let's get started. Arc length. The idea of arc length is I don't want the whole circumference, I only want a portion of it. So if I want that, usually I need this central angle, and that tells me the portion of the 360 I need. Voila. Okay, so let's take a look at this question. It says this AK goes through the center, and its distance is 18. So RDCA, it feels like AK is our, if you said diameter, you were right. So that would make the radius 9, the circumference 18 pi, and the area radius times pi. 9 times 9 times pi is 81 pi. Okay. Now, with everything established for given, let's see what else we know. So it says angle MRK is 121, MRK 121. Noticing that the measurement of this straight angle is 180 degrees. 180 degrees. So if you know that, kind of working backwards, that 180, if I take away that part, I'd get, all right, let me just double check my work there. 59. Okay, so that angle has to be 59. Because these two angles have to add up to 180. And so the measure of MRA has to be 59. And so we could find the arc length and just say arc AM is 59 degrees, but they want it in inches. So this is 59 degrees of our circumference. And we only want 59 out of the whole 360 of our circumference. Well, lucky for us, we already know our circumference. So we need to know 59 out of 360 times the circumference. That's the portion of the circumference we want. Okay, so I get 9.27. Rounded to 100th. Next question. It says when the radius is not known, we just make it r. So looking at the last question, notice that our circumference is 2 times the radius times pi. So our circumference is 2 times our radius times pi. 2 times 9 was 18, and then we multiplied by a pi. So to find the circumference, this would be what you would call maybe the formula. So here, we could write it like this. The circumference can be written like that because the circumference is 2 times the radius times pi. Okay, so in the problem it says the central angle is 30. So instead of the word central angle there, we can just put the number 30. And then it says the arc length is 10 pi. So instead of the words arc length, we can put 10 pi. And the rest, we don't know the circumference. So if I wrote, like the last problem, RDCA, I actually know none of the 4, and that's not usually how we usually know one of the 4. So that's why this problem's different. Okay, but here's what we do know. Usually we know the central angle, but we don't know the arc length. So that is making this different. So I can write this 2 times pi times r because that is what the circumference is. Now let's just do a little algebra. If I divide 2 pi on both sides, these will cancel. I notice 10 divided by 2 is 5, so I'm going to rewrite the equation we have here. This would be 5. That's still there, and this is our r. So it's still being kept there. So I notice I really liked how that I was able to cancel out. I'd love it if I could just write a 360 there and cancel that out. But But if you do that, you're going to have to put the 360 on both sides. I'd also like to cancel the 30 on the top with a 30 on the bottom because 30 divided by 30 is 1. So you could do that, but you got to do it here on this side as well. And now we will cancel. Awesome. Just R is by itself, and that's what we mean when we say solve for R. Here, let's figure out what that is. So 360 divided by 30 times 5. Okay, so that is 60. So my radius is 60. Let's just double check if this makes sense. So this is our answer, but we're going to see if our answer makes sense. So if the radius was 60, the diameter is 120, the circumference is 120 pi. So if all the way around is 120 pi, an angle of 30 degrees, let's see what that would be. That's 180. Right? So 180, I cut that in thirds, so that'd be 60. Each of these would be 60, 60, 60. So 60 times 6 is 360. I need a central angle of 30, so that's even a skinnier sliver. So notice this really skinny, sliver 30 degrees is not 1/6, that's actually 1/12 of our circle, and is 1/12 that, and that's actually true. 12 times that, that's 10 pi, another 10 pi, another 10 pi, another 10 pi, all the way around would make 12 pi's. That actually makes sense. Okay, so I double checked my answer. Now a fan is 5. Well, I can't really use my clock, but can you draw a star? So if you can draw a star or a star in a circle, that's one way to picture a fan that has 5 blades. So if I redrew my fan, lining up with these star points, I could make a fan blade here and about there, about there, about there. Really looks cool. Looks like a sand dollar, doesn't it? So that's a picture of a fan. Now, the diameter is 12. So radius is 6, diameter is 12. Circumference is 12 pi, and area would be radius times pi, or 36 pi. Okay, so now everything's set up. I don't want the whole circumference. I want to know the distance between any of these two fan blades. So instead of the whole circumference, I want 1/5 of the circumference. Makes sense where that number 5 came from. So 1/5 of the circumference, since that's our circumference, 1/5 our circumference is 1/5 of 12 pi. And we've got to round to that. So let's do it. 1 divided by 5 times 12 times pi. That's it. That's learning goal 1, arc length. Check out the next video.